Alright, so some people have been asking how exactly I make my BTR82, so I'm going to show you guys, just starting with a schematic setup and then how some of the internals work. So first, just standard Valkyrian Skies ship creation. Create a ship with the ship creator, throw the ship schematic onto the created ship, that way it assembles as a ship, and you don't have to worry about any glitches using what's the term? The helm. I kept thinking hull. Anyway, throw green armor or whatever armor on there. Framed blocks don't carry over in schematics, and then I'm just using. Oh, it is apparently turned off. Carpet, creative, no clip, true. Anyway, once you have the internals going, you want to hop in here, take a computer, this one is ID 0, and you want to just replace the computers because computers do not tend to carry over. And you want to make sure that all of the physical computers, why does this not pick up, are the same ID. And that's just going to ensure that all of your programs are exactly where you want them. Now, take a steel block, throw it on here, activate the bearing, lock the bearing, use this little bit that I left out of the schematic to rotate the bearing into place, throw one of these on there, wrench it, add the wheel. Now the wheel's working. Standard track stuff. Looks a bit nicer if you move some of the internal wheels a little bit inward. It just evens it out a little bit. And lastly, take the debug stick, and I had to use fences here because the turret will intersect with this wall and collide if it's a full block, so I just needed to use a fence. And just change it using left and right clicks so as to look like this. Looks just a little bit better than having to put a full block. There we go. And that's pretty much the external. And later I will use a suspension controller. But first, go in here, take the activated turret, throw the turret schematic on there, and activate. There's the turret. Gonna want to go in here and again break the computer, and the modem of course, and this is pretty much the assembled thing. It's a fairly simple schematic because I'm not using a drop-in turret or any nonsense, and that's the BTR. Now I have to activate it. So normally, right, you would go into your files. This is the same world that I've already used, so I already have the files loaded, but you would go into the computer, make sure that you replace it all with the same computer, and load the files that I linked into that computer's ComputerCraft folder. You're also going to want a advanced Ender Pocket computer from the controls. This one I use just computer ID 2 and computer ID 0. If it's your first world, it would probably be 0 and 1. But you just want to get all those computers lined up, and then you can go in on the rear computer, activate the pump one, or the pump program. That'll both turn on the engine and manage the steering, just because that's where I had a room to place the links. It's a bit silly, but then go into here. What intonation? Okay. Activate the transmission program. And lastly, to find the computer, this is where creative no clip comes in handy, or you can just use spectator mode. Activate this program. Oh, there it goes. Okay. Now you can see it stopped and it's in place. I can just take the computer, activate the controls program. You can rename these whatever you want. What the hell? Why is it overstressed? Alright, ignore that. I just had some issues because I had another BTR in my world and the transmitters got overloaded. So if you have multiple vehicles, just change the links on the transmitters. Anyway, once that's all together, you can see now it drives well. Turns a bit jank. You can move the turret around, stuff like that, drive around. And the stabilizer is on, quote unquote. You will want to drop it down and take one of your creative autocannon ammo containers, or just a normal one, throw it on there so that the gun can actually shoot. And so yeah, there is your functional BTR. It opens the trapdoors when it turns, which is a bit silly and annoying. Yeah. I'm sure there's a way to solve that, but I didn't, because I'm lazy. But yeah, you can see from the autocannon that the stabilizer is a bit janky. It stays roughly on the bearing, but it's not all that stable. I have some planned upgrades to it, taking into account the velocity, or the angular velocity of the vehicle. That way it doesn't lag behind by 1 tick worth of rotation. As you can see, it does, and also I have to fine-tune the autocannon's vertical angles a little bit. You can see the horizontal stays roughly on target, but the vertical gets all janky. That's just because I forgot to upgrade those. All that really entails changing little numbers in the code by small amounts until it starts being smooth. Basically just guess and check. But anyway, yeah, that is the BTR. And so now I'm going to go into the internals. Alright, so let's get into the internals. So, first thing is, the tank, or I guess the infantry fighting vehicle, has 8-wheel drive IRL. So I put that in here in Minecraft. And so you can see most of these bottom left and bottom right rows are taken up by a bunch of cogs that are powering the wheels. So here, we've got cogs here that are activated by this energy transmitter. It reverses here, but then it reverses again, so it's going. These are both going the same way, and so that works. You can't do that in the back, and so these are all powered just by normal energy transmitters, which does limit your speed a little bit, but because I mean you can't put too much stress in there, I don't think. But that's how the drive wheels work. You've got these links. They sit on the blocks adjacent to the wheels, and those will power the wheels when the links are activated. And obviously they have a sending link here, because the turret is in here, and so I couldn't fit a computer here. Anyway, you've got the turret. You do the rotation trick. By the way, the rotation trick, in order to do that, you take a ship, right? Or I guess you don't even need a ship. If you have a bearing, and it's going upwards, and you activate that bearing, right, it's going to rotate around its vertical axis. However, if you put a creative motor going into here, it's going to do nothing. But what you can do is use a wrench and rotate the bearing, and so now you see the turret works exactly the same as if the bearing was vertical, but it's accepting power from a different side. And so this allows you to make a turret ring that's only 1 block tall. Right? Just little quality of life thing. And so that's accepting power from this energy transmitter. Fairly simple stuff. What's interesting is the transmission. That's this computer here. And the way it's set up is I have 3 rotation speed controllers set up like this with the large cogwheels. And these large cogwheels, you can see they'll intersect with each other, so if I power one of them, it'll power all 3. And so I grab my engine, and what I want is for the shaft to be here. Oh, why does it not go? Here you go. Shaft's here. Problem is, if these both turn, one of them will snap off, because the adjacent connections from the wheel are going to intersect, or they're going to reverse the direction, and this shaft is not going to do that. So we can't have that. The trick to do that is throw an andesite casing on one of these cogs. You can see it no longer accepts rotation. You can use a wrench to make it accept rotation, or you can turn it off. And that way, I actually want to check something real quick. Oh, other way around, technically. This way accepts rotation. This way does not. And so when you put the shaft here, it's only going to power this one. All of the cogs are going to turn. All of the energy transmitters are going to work. Then you just throw a computer here, and what you can do with a computer is you can... Oh. Just had a world bug. But what you can do with these rotation speed controllers is you can take a advanced computer, throw it down here, and if we edit the transmission file, we can look down here and see that we use the object.setTargetSpeed and then a number, and that will automatically, you see this number, it'll adjust this number. So if we set it to 1, it'll go here. And the fancy thing is we can also set it to 0, and so it'll just stop. Can't do that manually, but with a computer it will work. And so by using those peripherals, this single computer can fully operate all 3 of these rotation speed controllers, have them move in any direction at any speed. And the trick there, this one in the back, is used to power the wheels. You just throw them on the end there. Obviously they would be more effective. And in this case, since there's 8 wheels, you just throw an energy transmitter and use that to power all of the wheels, and this one can power the other one. You see how on this side there's a shaft there and an energy transmitter. Here there's 2. That's just to save a little bit of stress units. A few stress units. Anyway, then on this side we'll put 2 energy transmitters down, and this allows us, you look down here, you see these allow us to transfer power to the gun and to the turret. So now with this computer and this setup, using the peripheral commands, we can have a single, very compact transmission that controls both the actual transmission and the turret drive, all in this one little compact area. Then lastly, we have just an engine with a computer that does the pump program, and then down on the bottom we have a creative fuel tank. And furthermore, this computer uses the parallel program, pump gear. It uses parallel programming to both activate the pump and get modem messages for controls. And so yeah, that's basically the internals for the hull. Just very simple, very compact computer-craft transmission that I got the design from N12 and I made the code. Simple pump. And then obviously this transmitter goes into the turret ring. This transmitter goes into the turret. This is the turret. Use a few boards to add a little bit extra armor just so it doesn't get taken out. And this one's very simple. It is just a turret basically. It's got a computer here, and the code is what's interesting, but the turret is literally just a normal controller. It's got some armor here so that, it has armor. If you shoot out the turret, the gun stays perfectly intact, which is a handy little feature. So you don't have to actually worry about getting shot in the turret, because none of the actual vital components, it's like 11:30, I'm tired. Any of the vital components are all activated in a way such that they have no hitboxes and cannot be damaged. You actually have to punch all the way through the hull, which this thing has no armor, so it's probably doable, but you take what you can get. Anyway, let's go look into the computer craft files. Alright, so I'm not going to go point by point in the code because it's very long and kind of convoluted, and that would take a very long time. You can go through, it should be mostly self-explanatory. I'll try to add comments that make it clear what I'm doing, but what I will do is just go over the math that I'm using, and then you can just compare that to the math that the code is doing. So basically, what we're using for the stabilizer is the ship API, which allows you to get the rotation of the ship in 3D space, either as a combination of pitch, roll, and yaw, or as a quaternion. Now, I prefer the quaternion just because I think the math is a little bit simpler once you get the hang of it. There are a couple of complicated files that you can see that it's called Hamilton, I believe, that run the calculations for a quaternion, where basically you put in a vector, which is a 3D vector except turned into a 4D vector by just making the first number 0, so it's 0 xyz. That's just your 3D vector, multiplied by the quaternion, and then multiplied by the inverse of the quaternion. It's kind of complicated. I'd recommend looking up the 3 blue, 1 brown interactive video. It's very elucidating. But basically what that allows us to do is to find the rotation of certain vectors in space. So if I take the vector 0, 0, 1, right, a vector that just goes straight up, like this red vector here, that, for example, represents the vertical axis of the cannon, right? If the cannon rotates horizontally, it's moving around that straight up axis. And then if the ship is flipped on its side, that quaternion will allow me to see, okay, that vector that would normally go straight up is now on its side. Instead of 0, 0, 1, it's something like 1, 0, 0, if it just flips over onto the x-axis. So that gives you your orientation in space. Mainly I'm doing it with 2 vectors. The axis of rotation of the turret, that vertical vector, and then the vector that is straight ahead in the turret. So basically where the gun's pointing. Unfortunately, because of the way Create works, I can't take the direction that the gun is pointing and as a ship API function because the gun is not a ship. So what I do for that is I take the direction that the front of the cannon mount is facing, and then I will record every time I put movement into the cannon in order to get basically a Riemann sum of the cannon's movements to figure out where it is. And then I'll add that. So the vector math I'm using is we have, let's say this red vector, let's say this ship is on flat ground, the red vector is the axis of rotation of the cannon, and let's say this blue vector is where the cannon is currently pointing. We have a third vector, it's the target vector, and this target vector, whenever you press a key on the controller, is going to move. So if you press left, the target vector will rotate to the left. If you press up, it'll rotate up, and so on. So let's say the target vector is here. Well, the ship just hit a bump, or a pebble in the road or something, and you can see the gun is not aligned. The gun's currently facing where this blue vector is. So if you want to have a stabilizer, it needs to get to where this purple vector is. Well, how do we do that? Well, it's a complicated problem because the ship is in 3D, but with a little bit of vector calculus, you realize 2 things. Well, first off, with the precondition that the cannon can only rotate around this red vector and up towards this red vector, right? You've got the vertical rotation and the horizontal rotation. You're basically working in spherical coordinates. So the way we do that is twofold. Number 1, we find the vertical elevation that the cannon needs to traverse by finding the angle between the blue and the red vector, and then finding the angle between the red and the purple vector. That's fairly simple. You do the cross product between the 2 vectors, divide by the magnitudes of the 2 vectors, which in most cases should just be 1 given the calculations, but I divide anyway to make sure, and that will give you the angle, or the cosine of the angle, between the red and blue, and between the red and the purple vector, and then you arc cosine, and you get the angle in radians. Subtract one for the other, that is the difference between the current elevation of the cannon and the elevation of the target. So in this case, the purple vector would be a little bit below. I'm not going to do the math, but it'll give you a number that says, okay, maybe like negative 0.2 radians or something like that. And so the cannon will lower by 0.2 radians. The horizontal is a little bit more challenging. And the way you're going to do that is by using orthogonal vectors. What that basically means is, okay, we have this axis here, and we want to know how far each of these vectors is rotated around the vector, or around the axis. Well, in Desmos, what we can just do, if it's 0, 0, 1, is we can just point it straight up. And so now, you can see we have just the orientation around the axis. And so this one is at approximately 0 radians, well, exactly 0 radians. And this one's at, I don't know, maybe like pi thirds radians, somewhere around there. That would be simple, right? Well, in this case, we just find the component of the vector that is on the xy plane. Does that make sense? You just project these vectors down onto the xy plane. That way, you can see now they're exactly lined up with these vectors when we're facing straight down, but you can see they're on the same plane. They're on the plane of rotation, and so you could just again use the cross product to find the angle between these two vectors. Fairly simple. Problem is, the way I did it is I just deleted the z component. You can't always do that, mainly because it's not always straight up. Maybe it's on a hill, slightly off center. Well, now how are you going to do that? Well, the trick, if I just get rid of these, for example, is to use orthogonal vectors. Right? This green vector is the orthogonal vector, or the orthogonal component of the blue vector with respect to the red vector. The way you find that is you find the, let me just copy paste this here, you find the projection of this vector, you find the projection of the blue vector onto the red vector. Obviously, with your cross product stuff, if you haven't learned vectors, it's probably going to go over your head. But you just take, where is it? I need to get rid of the y component. No, I'm tripping. I need to get rid of the x component. Ignore me. So here, you see you have the projection, right? And an easier way to visualize this is if I just take the orth vector and move it up by this much. This is basically what you're looking for. You've got this blue vector. You can see this green vector here is the same vector. If you have a normal vector, it's just going to be from the origin. So here I've just moved it up for visuals. It's going to be at 0.3, but it's just the vector component of this blue vector in the xy plane. The way you find it is you project the blue vector onto the red vector using the cross product. So in this case it would be blue, the unit vector of blue times the cross product of blue and red divided by the magnitude of red. Then subtract orange from blue and you get green. And that's basically the vector calculus that is involved. You just project these onto the axis of rotation, find the angle between them. That's where the cannon needs to rotate horizontally, and that's pretty much it. Except obviously vertical as well. Find the angle, find the difference in the angle, then you have the difference in the vertical angles and the difference in the horizontal angles. You rotate the cannon, and everything works nice. Oh, there's one more thing I forgot to mention for people who are not familiar with this mod pack. Tally-ho items do not carry over on schematics, so just grab a periscope, click on this block, it's down there. You can hop in, you can add a thermals block where the seat is. That lets you see in the thermal scope. You see the sheep is lit up, so it's helpful for night fighting. It does not track with the turret, just because the turret is very hard to fit a scope on, and when these are closed, you can see out of the periscope to maneuver. Anyway, that's about all I could think of for the BTR. If anything isn't working, or if I should go into more depth, just let me know, and I'll be happy to. Anyway, have a fantastic day.